does this equal to? Because I would like us to establish this and not have to think about it again.
A squared plus 2ab plus b squared for
Awesome.
the first, and,
Yes, so it's
and a squared minus 2ab plus b squared for the second.
Okay, so Brandon, thank you so much. So I'm writing your every time you answer. It's awesome for me. So Brandon, and in this way I learned your names as well. Okay, so for those of you who don't remember this, I'm going to just quickly show you that a plus b squared is the same with a plus b times a plus b. I don't want us to always FOIL this, because then we're going to have more work to do with other things, right? So we should understand that a binomial, two terms, binomial squared equals a trinomial, 3 terms. A binomial squared is a trinomial. So how would you just get back into this? So just FOIL. So this is a squared plus ab plus ba, which is written as ab, and plus b squared. That's how the 2 shows up here, because there are 2 terms that are like terms, and that's why we have 2. So moving forward, I would like us to remember that 2x minus 3y, let's say, squared, has to have 3 terms, because this is negative. The middle has to be negative, right? And how do I get the a squared? By simply squaring this. How much is 2x squared?
4x squared.
Very good. Awesome. And that was Hersh and Kim. Very good. Okay, so now, of course, the last one is this squared. So what is it?
9y squared.
Very good. It is 9y squared. And of course, this is always positive, no matter what. Always, no matter if you have positive or negative. And the middle one is the 2 times the first term and times the second term. So multiply these 2 to get 6xy, and then multiply it by 2 to get the 12xy. Okay? So I would like us not to get stuck on foiling all the time, because this class has topics that are way more sophisticated than having to deal with this. So that will be the starting point for us. Okay. So, and there is another special product. There are others, but at least these 3 special products. Can anyone give us, other than Kimmy and Hersh and Brandon, anyone else can tell us what this is? It's okay if you're wrong. I just want to...
B squared?
Yes. This is the difference of squares, indeed. And remember, A and B, just the different symbols in the middle. So, I don't know, x squared minus 2y squared. What would be the next one? So I can apply this special product.
The other one would need to be x squared plus 2y squared.
Very good. So then what do we get? And remember, the middle, the symbol has to be negative.
X to the 4th minus 4y to the 4th.
That's it. Again, you can FOIL this. But then when we get to sophisticated stuff like integration and differential equations and multivariate calculus, then we're going to get stuck. So please work on this. And when you come back to the study groups, if this is not clear, we'll have more time to work on that. So that was the first day agreement. And I like to say to my students, this is forever. And I like to joke and say, I said here first, the agreement valid forever, no expiration date. You know, if I call you at 3 a.m. 100 years from now, just kidding. Okay, so back to modules. So a lot of this material that you will see here in the prereq, if my computer cooperates. Hello, computer, wake up. Okay, it's awake. A lot of this stuff will appear again and again and again and again. So just take a look. We have about 25 minutes left. I'll do whatever you want me from here, whatever you catches your eye. I did work with my study group today on something like this, and something like this, and something like this. It doesn't have to be this sophisticated. This was an example that I created, but it doesn't have to be this sophisticated. So graphing a piecewise.
Excuse me.
Yes, I'm ready.
The only one I'm seeing not having trouble with confuses the bottom. That one's a difference quotient one, right?
Yes. Yes, this is the
Yeah, I
difference.
usually just see it without them not being in a denominator, so I just wanted to make sure.
Okay. So what would you like to continue? Piecewise defined function. We can talk about the difference quotient already, or anything else.
Could we go over the piecewise
Okay,
function?
very good. I'm gonna make one up. Very good. So okay, so who cares about the piecewise defined function? Well, they have a lot of applications. So let me give you an example. I'm just making one up. So let's say we want to post a parcel to, I don't know, domestic or international, it doesn't matter. So if it weighs between 0 and 10, whatever measurement unit you want, doesn't matter, then we pay $10. If it measures between 10 and 30, not 10, right? So closed at 0, open at 10, closed at 10, open at 30, one or the other, it doesn't matter. I can close here or open here, it doesn't matter, but not the same, not in both. Let's say it costs $20. Now between 30 and 50, okay, now this is costing us $30. This is a piecewise defined function. So for a certain weight, this is the function. For another weight, this is the function. For another weight, this is the function. Okay, is there another example? Oh yeah, it's coming up in April. What is it? April 15th.
Taxes.
Yes, taxes, right? So for somebody who earns between 0, I'm making up the numbers, I don't know. Okay, let's say they pay, they pay 10%. For someone from 30,000 to 50,000, let's say, I don't know the numbers, but 15%, and so on and so forth. This is a piecewise defined function. Okay, so here's an example. Let's say 2x plus 4 for x less than or equal to -1. And let's say minus x plus 3 for x greater than -1. It has 2 pieces. Can I make it 3? Yes, I can continue with as many pieces I want. But let's say 2 pieces. And now the scope of all this is just to graph it. Graph the function. Now, if I end up graphing something like this, will this be correct? In other words, I'm asking, is this a function?
Yes.
Careful. If you don't say anything, even if you're wrong, then I will not know how to correct it. So please always tell me what comes to your mind. Yes, Manuel, go ahead. You wanted to say something?
No, I was gonna say it's not a function because the lines are crossing
By the
by the I forgot the name.
vertical line test, this
Exactly.
cannot be a function. But what if I graph something like this, where this is a full point and this is an open point? Is this now a function?
Yes, it is. I believe it's a function.
Yes. So please always be very careful when you see a function that is defined in pieces, 2, 3, 4 pieces, doesn't matter. Do not ever graph the pieces overlapping, because if you do, it's totally wrong, right? We understand that? Is that a yes?
Well, I have some doubts. Can you give another example if possible?
Oh, I didn't graph the function. I didn't do anything. I'm just saying from the very beginning that if when we graph this function that is made up of 2 pieces, if we end up graphing like this, it means that we know very little or nothing about piecewise defined functions. That's all I'm saying. I haven't graphed anything yet. Okay, so now our first step towards graphing is domain. Every time we're asked to graph, we have to start with a domain, no matter which function and how it looks like. So in this particular case, I'm going to change this inequality into an interval notation. Can anyone tell us how to? It's okay if you don't remember. How do I change this in interval notation?
Would it be, it would be parentheses, infinity, comma, -1 bracket?
Yes, but you mean negative infinity, -1 bracket. Awesome.
I'm sorry, that is what I meant.
I
don't
know.
what I said.
I know
that's
exactly
I'm
what you
trying to
meant.
say.
Can anyone give us this?
-1 bracket, comma, to infinity.
Good. But if I use bracket in both, I'm in trouble. It's not a function.
Yeah, so it'd be open on both sides.
Yes.
Or
Yes,
equal
because
signs.
it does not have the equal symbol. Who was that, Sarah?
Yes.
Thank you. Good. So now, can anyone establish a domain of this function, looking at this and this?
Is the domain where you take both of those and then you separate them by the U?
But I have -1 and I don't have -1. Do I really need the union?
You wouldn't need it, right? So
That's
it'd just
it.
be negative infinity to positive infinity.
Excellent, Rachel, thank you. Excellent, good, awesome. Number 2 is a table of ordered pairs. Mandatory table of ordered pairs, please. Domain established already by you, thank you. Which X value has to be in the table always and forever?
0.
Excellent. And now let's look at our piecewise defined function and say there is another key X value. And the key X value is
Would it be -1?
Of course. Why? Because something happens at -1. The function changes from this to this precisely at -1. Great job. Notice that at -1, that's why I wrote this. We notice that there is a bracket facing this way, and there is a parenthesis facing this way. These are the two symbols that will be touching one another, and they will be written exactly, or drawn if you want, exactly under -1. Not like this. Exactly under -1. You will see I have my props. These are my props. You'll get used to them. Kidding. Okay, good. So now I'd like you to tell me which function I use for this and which function I use for this. And you can say they're right there. Why do you make me write them again? Why? Here's the answer. Because these sometimes are intentionally reversed. And if I don't write them correctly above the table, I may substitute in the wrong one. It's not difficult to do. Okay, so then, which function I use?
2x plus 4.
That's it. And of course, obviously, -x plus 3. What type of functions are these?
Linear?
Very good, linear. For linear, we need 2 points. So if I have 1 point, I can draw infinitely many lines. But if I have 2 points, I can only draw 1 line through 2 points. Okay. So can anyone give us the x-intercept? So I solve this equation f of x equals 0. Remember, we move forward to the other side. When I move a term from one side to the other, all that happens is just, change the sign. And divide by 2, so x equals -2. So right in here, I'm going to move my infinity slightly to the left to make more room in my table. So -infinity and -2, and I have 0 under -2. Now, please plug in -1 in this function and tell me what you write inside the bracket.
2.
Yes, so 2 times -1 plus 4 is indeed 2. So please plug in -1 on this side, and you should say no. Why?
Would the right side be 4 then?
I'm sorry?
In parentheses.
Yes,
So if
because
that's on the left, on the right, do you put 4?
So on the right, I will put 4 right inside of the parenthesis. And I will plug in 0 and get 3. And I will also plug in 3 because I get 0. I always look for the x and y intercepts. Always. Any questions so far?